Alright, so resonance happens when filled-empty orbital interactions occur within a molecule. For a filled-empty interaction, we need two pieces. We need the filled orbital and the empty orbital. We call the filled orbitals electron sources. They are filled high-energy orbitals. Electron sinks, on the other hand, are the low-energy empty orbitals that the electron sources donate into. So on a molecular orbital diagram, we would just represent those with horizontal lines. I'm going to talk now a little bit about typical electron sources and sinks that you'll see as you recognize compounds for which resonance is important. So the idea is, if you spot a potential electron source in a molecule, look for an empty orbital nearby, and if you can spot one, then you know that resonance is important to that molecule. So electron sources are high-energy filled orbitals. What are the high-energy filled orbitals? Well, as I just said, recall the typical energy ordering of molecular orbitals. The lowest energy, the most stable, we have the sigmas, and then the pi's, the n's, and then the pi star and the sigma star. I'm repeating this because it's really important as sort of a take-home message. And again, we typically see these three bottom orbitals filled. And so typically, the highest energy orbitals that are filled, that are occupied with electrons, are either non-bonding lone pairs, so those correspond to lone pairs, and the pi orbitals correspond to double or triple bonds. This is why typically we see n and pi orbitals as the typical electron sources. So if you see a heteroatom like nitrogen, for instance, with a lone pair is a great electron source. A pi bond, such as the pi bond of an alkene, tends to be a great electron source. The triple bond of an alkyne can serve as an electron source. And of course, heteroatoms can be involved in these as well. So the pi bond of a carbonyl is a great electron source. The pi bond of a nitrile is a great electron source. And you can see that all of these correspond to situations where the atoms or the groups are relatively electron rich. So we have a lot of electrons, right? 3 lone pairs involved in the triple bond, and unsurprisingly, the electrons in the triple bond can serve as a great electron source. Other examples of heteroatoms: oxygen, lone pairs, and lone pairs on the halogens, which I'll just represent as X, often serve as great, relatively high energy electron sources. Getting into electron sinks, again drawing up this orbital energy ordering one last time here. Oops, drew one too many lines there, sorry about that. But we typically see that the empty orbitals, the lowest empty orbitals, are the pi star, pi antibonding, and also unfilled atomic orbitals, which I haven't actually drawn in, but those are typically a little bit higher than the n orbitals, and we call those A for atomic orbitals. Most often they are p orbitals, so we'll take a look at that when we look at the typical structures that provide electron sinks. So electron sinks are your low energy empty orbitals into which the sources donate for resonance structures. So typically we'll see either pi star or A orbitals as the lowest energy, most reactive empty orbitals for resonance structures. So the typical Lewis structures you'll see that correspond to that are, of course, the basic pi bond can serve as a source, a sink. So notice the pi bond can serve as both a source and a sink. So pi bonds are critical to resonance, and the wiki has more information about how pi bonds can serve as sort of resonance relays and transmit the information between two distant electron sources and sinks. A orbitals are most often going to be empty p orbitals on carbocations. So the empty p orbital of a positively charged carbon can serve as a great electron sink. Triple bonds also can serve as, that should say sinks rather than sources, my apologies. Triple bonds can also serve as electron sinks. They have relatively low energy pi star orbitals as well. So again, it's really the pi star and A orbitals that are going to come into play here. And heteroatoms, again, are just as applicable here as in the sources. So the nitrile can serve as an electron sink. An interesting electron sink is the boron atom. So neutral boron actually has a free p orbital that's empty. And this can serve as a great electron sink in resonance structures. The pi bond of the carbonyl is a great electron sink. That pi star orbital is very low in energy, and so that can serve as an electron sink as well. And remember that in all of these cases, even though I draw arrows to the electrons, it's really the empty orbitals corresponding to those bonds that serve as the electron sinks. So whereas the pi orbitals can serve as electron sources, the pi star orbitals can serve as electron sinks for double and triple bonds.